Okay, problem number 2. A tractor weighing 3,000 pounds with a wheelbase of 9 feet carries 1,800 pounds of its load on the rear wheel. Compute the maximum moment and maximum shear when crossing a 14 feet span. So meaning to say you have a beam which has 14 feet, that is the span, and you're going to compute again for the maximum moment and maximum shear. So we have here the figure. So for this figure, if you're going to observe, we have the rear wheel, which is 1,800. We are given with the result 3,000, but we don't have the value for our front wheel. So we have to compute for our front wheel. So this is actually R is equal to W's of R plus W's of F. So R is 3,000. So this is equal to our real wheel is 1,800 plus our front wheel, which is unknown. So we can compute for the front wheel, which is equivalent actually to 1,200 pounds. Now we can compute for our x. So what will be the value for x? What is the value for our x here? So to compute for x, let us have our reference point on the rear wheel. So this will be our reference point. So if that will be our reference point, so this will be, you have the resultant force R times distance x. Then this is equal to, you have the front wheel times the moment arm distance, which is 9. So we have computed for the front wheel. So R is also given 3,000 times x is equal to 1,200 times 9. So x here is equal to 3.6 feet. So we have now the value for our x. So therefore, our 9 minus x here, this distance, 9 minus x is equal to 9 minus 3.6. It will give us 5.4 feet. So we have now our specific value, which is 5.4. Okay, so if we place our resultant and if we place rather our center line, this is our center line of the beam. Okay, the beam has a span of 14 feet. So if we try to put the resultant and if they try to put the center line in midway between the resultant and the rear wheel, so our front wheel will be outside the span. So meaning to say we only have one load that is acting. So we have only the rear wheel, which is 1,800. So therefore, we are going to have, of course, this is 3.6. So we have here halfway is 1.8, 1.8. So if this is 1.8, 1.8, so therefore this is 7 minus 1.8, so we have 5.2. So the other side is also 5.2. So therefore, as mentioned, we only have one force or one load acting. We have the rear wheel. So this front wheel will be outside. So therefore, if we try to have our resultant, meaning to say our R1 and R2 will be half of 1,800. So R1 is equal to R2, and this is equivalent to 1/2 of 1,800. And this is actually equal to 900 pounds. So we have now your value for R1 and R sub 2. Now, if we're going to have now the maximum moment under the rear wheel, so let's have the maximum moment. Under rear wheel, W sub R. So if we try to consider the rear wheel, so this is our span. So put that in the center line, so W sub R. So we have here R1. This is our R sub 2. So therefore, this one is 7 feet. So if we're going to have the moment to the left of rear wheel, so this will be equivalent to, you have the moment to the left of rear wheel, so to the left of this rear wheel, so we consider this one. So we only have resultant force R sub 1, so therefore having this as our reference point, so that will be R1 times 7. R1 is 900, so times 7, so we have the value of 6,300 pounds feet. So we have now our specific value. Then if we're going to have maximum moment under W sub F, so if we try to have the maximum moment under the front wheel, W sub F. So we're going to place our center line. This is our center line in between our W sub F, and this is our resultant force R. And of course, we have our W sub R. So this is our R sub 1. This is our R sub 2. So this has a distance of 3.6. Of course, this distance is 5.4 as we have computed a while ago. That is 5.4. So half of this towards the center line is 2.7. So this is also 2.7. So therefore, this one is 7 minus 2.7 is 4.3. So this is also 4.3. So therefore, we're going to have summation moment. If we're going to have the reaction forces, summation moment R1 equal to 0. So this will be our reference point. So we're going to have R sub 2 in a counterclockwise direction times moment arm distance 14. Then our resultant force in a clockwise direction, that is 3,000 times our moment arm distance, which is 4.3. So therefore, our R sub 2 is equivalent to 921.43 pounds. So we have now the value for our R sub 2. Then we're going to have now the maximum moment. Moment to the left, to the right of front wheel. So this will be equivalent to, so if this will be our front wheel, this is our front wheel. So moment to the right of the front wheel, so we consider this portion. So that is R sub 2 times 4.3. So therefore, this will give us 921.43 times 4.3, and this will give us a value of 3,961.2, 3,962.1 pounds feet. So we have now our value for our moment to the right of the front wheel. So based on our investigation and our solution, so we have arrived with our maximum moment. So therefore, thus, our maximum moment, based, if we try to compare, so we have 3,962.1. This is under the front wheel. This one is under the rear wheel. So our maximum moment occurs under the rear wheel. So this is 6,300 pounds. So we have now our value for our maximum moment. Then we're going to compute for the maximum shear. So as mentioned, maximum shear will occur when the bigger load is placed under the reaction, reaction. So under the support rather, that is placed under the support. So our maximum load is 1,800, which is on the rear wheel. So we place that one at R sub 1 on this support. So this is W sub R, which is 1,800. And so basically this is our resultant R, which is 3,000 pounds. And we have our W sub F, which is 1,200 pounds. So therefore, this is our R sub 2. So from there, we could identify this one as 5.4. This distance from the resultant towards the front wheel is 5.4. This distance is 3.6. So you have that value. And of course, this one is 10.4. So basically, we can compute now for, let's have our R1. So we're going to have the maximum shear. So we place our rear wheel under R sub 1, and this will have the maximum shear. So moment at R sub 2 is equal to 0. So this will be clockwise direction, R1 times 14. Then we have the resultant force in a counterclockwise. So minus R times the distance, moment arm distance is 10.4 equal to 0. So R1 times 14 minus our R is 3,000 times 10.4 equal to 0. So therefore, R1 here is equivalent to 2,228.57 pounds. So therefore, our maximum shear is equivalent to 2,228.57 pounds. So we have now our specific value for our maximum moment and maximum shear for this given problem.